All right, so now we're going to take a look at example 3. So example 3, we're given a picture of a graph, and it wants us to identify the x and y intercepts. So based on the picture of the graph, we can see here that it crosses the x-axis, and actually we got to do a little bit of digging into what this scale is because they don't tell us. So let's see here. We have 1, 2, 3, 4 tick marks to get to this 20 point, which means we must be going by 5s. So this right here must be 30. So our x-intercept is when x is equal to 30. Our y-intercept is at a nice value of -50. Now, if you look at your textbook, it goes through and it writes them as ordered pairs. I really don't care which way you write it, saying x equals and y equals, or writing it as an ordered pair. Both is fine for me. Next, let's go through one last example problem, and it says, for the given linear function, determine the x and y intercepts. So let's go through this process one more time, and then if you do have any additional questions about finding x and y intercepts after watching each of these examples, please reach out to me and let me know. So we have 15x plus 30y equals 120. So a little bit bigger numbers this time. First, we're going to find our x-intercept. Again, the process for finding x-intercept is plugging 0 in for y and solving for x. Plugging 0 in for y, 30 times 0 is just 0, so I'm left with 15x equals 120. From there, we'll divide by 15. Because that's the opposite of multiplication. And we get 8. So we know that our x-intercept is at x equals 8. Next, we're going to find the y-intercept. Finding y-intercept is plugging 0 in for x and solving for y. So in doing so, I end up with 15 times 0, which is just 0, plus 30y equals 120. So that simplifies down to 30y equals 120. Solving for y, I'm going to divide by 30 because that's the opposite of multiplication. And I get y is equal to 4. So I know that my y-intercept is when y is equal to 4. All right, and that wraps up the Concept 4 lesson.